Hello friends, this is the continuation of the chapter Mensuration. In this mensuration, we saw about square, circle, rectangle and triangle, isn't it? Now we will see about three-dimensional objects like cube, cuboid, cylinder and so on. Okay, so first let us take the case of a cuboid. Now what does a cuboid look like? This is how a cuboid looks like. Okay, I hope you get it. This is how a cuboid will look like. Now these are the surfaces that is present in a cuboid. How many surfaces are there? You have 1, 2, 3, 4, 5 and 6. Okay, so these are the surfaces of the cuboid. So the area of all these surfaces together will give us the surface area of a cuboid. Okay, now we have drawn this figure of to know what do you mean by the surface area of a cuboid. So how many faces does a cuboid have? 1, 2, 3, 4, 5 and 6. So this is the height of the cuboid. These are the lengths and breadths of the cuboid. So how will we calculate, what is the formula for surface area of a cuboid? It is nothing but 2 into LB plus BH plus HL. I hope you understood this. Okay. So in this case, H, L and B are the height, length and breadth respectively. So area, since surface area is given by the, it is an area, the unit for this will be m squared, centimeter squared and so on. I hope you understand. Now we'll go to the lateral surface area of a cuboid. Now what do you mean by lateral surface area? When you have a cuboid with the top and the bottom open, that is a cuboid without the top and the bottom is called as a that surface area is called as the lateral surface area. I hope you understood this. That is without the top and the bottom, that is without the top and the bottom, only the curved surface area, only this area is called as the lateral surface area of a cuboid. Now what is the formula for the lateral surface area of a cuboid? It is 2h into L plus B. Now we will see about the volume of the cuboid. What does mean by volume? Volume is nothing but, suppose you take a cuboid and you take a container which looks like a cuboid, any metal container or anything, and you fill it with water. The quantity of water that the container can hold is called the volume of the cuboid. I hope you get it. So this is called as the volume of the cuboid. It is given by length into breadth into height. Okay, I hope you understood this. Now we'll go to a cube. Now a cube is nothing but it is a square in a three-dimensional form. A square in a three-dimensional form is said to be the cube. So in a cube, all the sides are equal. So it is L into L into L. How many faces does a cube have? It has 6 faces. So the surface area of the cube is nothing but 6L squared. I hope you understood this. Surface area of the cube is 6L squared, where L is the length of the side of the cube. Okay. Volume of a cube is given by L cubed. L into L into L is L cubed. Okay. Now we'll go to the cylinder. What is the surface area of a cylinder? Now this is a cylinder. I hope you understand. This is nothing but a cylinder. Okay. So now when this curved surface, you are able to see this curved surface, isn't it? This curved surface is called the surface area, along with the both top and the bottom together is said to be the surface area of a cylinder. We can also take a rectangular sheet like this, and if we fold this into a, this is nothing but this is a cylinder. I folded this paper into a cylinder. So a rectangular sheet can be folded into a cylinder where there are two circles at the bottom and the top. Okay. So that is the surface area of a cylinder. It is given by 2 pi r into r plus h. Now volume of the cylinder is equals to pi r squared h. The lateral surface, what do you mean by lateral surface? That is a surface area without the top and the bottom is called as the lateral surface area of the cylinder, which is nothing but 2 pi r h. Okay. So these are the formulas, you have to memorize them. Now we'll go to the next topic, that is the problem. Daniel is painting the walls and ceiling of a cuboidal hall with length, breadth and height 15 meters, 10 meters and 7 meters respectively. From each can of paint, 100 meters squared of area is painted. How many cans of paint will she need to paint the room? Okay. Now what are we given? We are given the dimensions of the cuboidal hall. So the length of the wall is 15 meters, breadth is 10 and height is 7. Okay. What will you calculate? Will you calculate volume? Will you calculate total surface area? We will calculate the total surface area, not the volume, because we have been asked to find the area of the painted walls. It is not the volume. Volume means the capacity. Okay, the total capacity a cuboidal container can hold. Here it is not the volume, it is a surface area. Total surface area is nothing but, we learned the formula as 2 into LB plus BH plus HL. But here LB, in the case of a cuboid, if this is the cuboidal room, one side will be left unpainted because it is the entrance, isn't it? When you paint a hall or a room, the entrance will be open, isn't it? So there is the LB is only once, it occurs only once, but the others occur twice. Okay, so we will calculate it as length into breadth 15 into 10 plus 2 into BH plus HL, that is 10 into 7 plus 7 into 15. 15 into 10 is 150, 10 into 7 is 70, 7 into 15 is 105. We add them up and we multiply. We get 150 plus 350, which is equal to 500 meters squared. Calculation part, I think you can do it on your own. Okay. So number of cans is equal to area of the hall. Area of the hall is 500 meters squared plus number of can. We are given that one can paint 100 meters squared of area. So 500 divided by 100 is equal to 5 cans. Okay. Now you should understand here we took the surface area in such a way that the LB occurs only once. Okay. So keep that in mind. You should not use the formula as it is. In context to the question, you have to use the dimensions. Okay. I hope you understood this. Yes. Now we'll go to another problem. The lateral surface area of a hollow cylinder is 4224 centimeters squared. It is cut along its height and formed a rectangular sheet of width 33 centimeter. Find the perimeter of the rectangular sheet. See, now this is a hollow cylinder. Hollow cylinder means the top and the bottom is open. It is not closed. So I told you, when a rectangular sheet is folded, you get a cylinder, isn't it? So you have to find the lateral surface area of the hollow cylinder. In this case, you are not supposed to find the surface area, it is the lateral surface, because it is a hollow cylinder and they have given that the lateral surface is 4224. So lateral surface area of the hollow cylinder is 4224. Height of the hollow cylinder. So this distance, this rectangular sheet, this is the height. Okay. The height of the hollow cylinder is 33 centimeters cube. Curved surface area. Curved surface or lateral surface, both denote the same. What is the formula for the curved surface? It is 2 2 pi r h. If this is h means this will be 2 pi r. I hope you understood. In the case of a rectangular sheet, if this is the height, then this will be 2 pi r. We are given that 2 into 22 by 7 into r into 33 is equals to 4224 RH, isn't it? We know the value of H, we don't know the value of R. So we'll keep R here. We'll take all the other quantities to the other side. We will reduce it into the form. We get 64 into 7 by 22. Now, length of the rectangular sheet is 2 pi r. I told you, isn't it? This is the rectangular sheet. If this is the height, then this is 2 pi r. Because, let me take this rectangular sheet. If I fold this, this will form into a cylinder. I hope you get, isn't it? This is a cylinder. So, this length is 2 pi r and this is the height. Okay. So, length of the rectangular sheet is equal to 2 pi r. That is nothing but the length. Length is equal to 2 into 22 by 7 into r. This is the r value. So finally I solve the problem and get 128 centimeters. I hope you all understood how we solve this problem. Okay, now we are asked to find the perimeter of the rectangular sheet. Perimeter of the rectangular sheet is nothing but 2 into length plus breadth, which is nothing but 128 plus 33, which is 2 into 161, that is 322 centimeters. Length we got it as 2 pi r. Now what is the breadth? Breadth was given as 33. I hope you understand breadth, height, all of them will always be denotes the same. Okay. A company packages its milk powder in a cylindrical container whose base has a diameter of 14 cm and height 20 cm. Company places a label around the surface of the container. If the label is placed 2 cm from top and bottom, what is the area of the label? See, the label covers the cylinder, isn't it? So it is the surface area. You have to calculate the surface area and not the volume. Okay, so this is the package, or this is the container and this is the label. The total dimensions are 14 centimeter is the diameter and the height is how much? 20 centimeter. But we are asked to find the surface area of the label, isn't it? So this will be nothing but 2 centimeters from top and 2 centimeters from bottom we have to subtract. Okay. Now we will see how we solve it. Given diameter of the cylindrical container is 14 centimeter. Therefore, radius of the cylindrical container is 14 by 2, which is equal to 7 centimeter. Height of the cylindrical container is 20 centimeter. Height of the label is equals to 20 minus 2 minus 2. See, if this is the cylindrical container, the label is placed over here. The label is 2 centimeters from the top and 2 centimeters from the bottom. The label is above that, isn't it? So we subtract 20 minus 2 into minus 2, which is equal to 16 centimeters. So curved surface area of label is equals to 2 pi r h, which is equal to 2 into 22 by 7 into 7 by 16, which is 704 centimeters squared. I hope you understood how we solve this problem. The label is 2 centimeters above the bottom as well as from the top it is 2 centimeters below. So we subtract 2 times from 20 to get 16. That is the height of the label. Okay, R is given. So we can use the formula for curved surface of a label. I hope you understood. Thank you, friends.